So this lesson is on page 5 of your unit handout. It's just a continuation of the same textbook section, but we're doing different things now. And then on Monday, it's going to be part 3 of this textbook section. What we're doing today is dividing expressions when the denominator is a monomial. Okay, if the denominator is not a monomial, that's for Monday. So we're dividing radical expressions, and we're doing something called rationalizing denominators. When you rationalize a number, you change it into a rational number. Root 2, if I say, what is root 2 equal to? Well, I'll ask you that question. Who can tell me what root 2 is equal to? What is root 2 equal to? Somewhat of a trick question. Because I see some of you going for your calculators and you're going to go, oh, it's equal to 1.41. And I'll go, no, it isn't. And you go, oh, it's equal to 1.41 something. And I'll go, no, it isn't. What is root 2 equal to? Root 2. It's an irrational number. You cannot express it as a decimal. Is the number 2 rational? Yes. Because it's exactly equal to 2. No decimals. So we're going to be taking denominators that are not rational and changing them into denominators that are. To begin with, we have the same kind of rule that we had before with multiplication. With multiplication, you multiply coefficients by coefficients and radicands by radicands, and the same thing is true for division. When you're dividing a radical by a radical, you divide the top radical by the bottom radical. There's a lot of ways of saying this, but to begin with, can you confirm on your calculator that root of 352 over 17 is giving you the same answer as root 352 over root 17? Does. And the point I'm trying to convince you of here is if I have root 352 over root 17, I can divide the radicands and take a single root. Not that I want to write answers in decimal form, but it works. So how are we going to use this? What is root 960 over root 120? What is it exactly equal to? Well, we are allowed to do this. And you can use your calculator for this. I want to say that it's 8. It's root 8. That 960 over 120 is 8, isn't it? Okay. So that means that root 960 over root 120 is root 8. And I hope you would agree that's a lot simpler. Are we done? No. Because you always have to simplify radicals if you can. And root 8 is one of those that is very simple to simplify. It's 2 root 2. Very basic question. And the only thing you really did on your calculator was take 960 divided by 120. Right? You're not taking the square root on your calculator. Let's try another one. Bless you. Negative 7 root 256 over 14 root 32. Well, the negative, let me break this down for you. Am I allowed to think of it this way? Well, of course I am, because when you multiply fractions, you multiply across the top and across the bottom. So there's no difference here between saying it's negative 7/14 times root 256 over root 32. There's no difference between that and saying it's negative 7 root 256 over 14 root 32. And this illustrates my point that if you focus on this fraction, you are allowed to divide those numbers. By divide them, I don't mean put them in your calculator. I mean figure out what 7 over 14 is as a fraction in lowest terms, and that's 1/2. Correct? So this becomes negative 1/2 times the square root of 256 over 32. Just like we divided 7 by 14 to get a half, we divide 256 by 32 to get what I want to say is 8 again. So we end up now with negative 1/2 times root 8, which is negative 1/2 times 2 root 2. And 1/2 times 2 is 1, so we're left with negative root 2. That's the answer. Now I want to go back to the beginning here. You didn't need to do all of this breaking it up into two fractions. You could have just said, well, it's negative 1 over 2 root 8. You can divide the coefficients and you can divide the radicands. And when you simplify that, you get negative 2 root 2 over 2. So you're still left with negative root 2. All of that other stuff in green, that's just me explaining why it's going to work. Okay, can we divide 80 by 15? I don't mean can we, are we allowed to? Yes, because they're both coefficients. And I know that 5 goes into 80 and 5 goes into 15. I think it's going to be 16 over 3, am I right? Okay. So when we reduce the coefficient part of this down, we get a 16 here and a 3 there. Can I divide? So I'm not going to rewrite this. I'm just going to go over here and say, can I take 432 r to the 5 divided by 72 r cubed? Can I do that? Sure, I can because they're both radicands. And r to the 5 over r cubed is r squared. So we're going to have an r squared underneath that radical. And 432 divided by 72, I'm going to guess is 6. Is it 6? So you divide the coefficients, which in this case meant simplify them as a fraction. You divide the radicands and you're left with a radical of root 6r squared, because this is 6r squared over 1, right? Can we simplify this? Yes. By the way, in this example, r has to be greater than or equal to 0, because you can't take square roots of negatives. Yeah.
Are you going to, on an exam, are you going to ask us if it's has restrictions or not?
If I want to know if you know what the restrictions are, I'm going to ask you that. I'm not going to expect you to write it unless I prompt you to. Okay. Is that an answer to your question? Okay. All right, and now rationalizing denominators. For whatever reason, and I could make up a reason, but it doesn't matter. The typical standard practice is we don't like radicals in a denominator of an expression, okay? The reason why I don't want to really give you a reason is if you go on and take calculus, you're going to find cases where we don't want radicals in the numerator. It just depends on the situation. So in order to prepare students for advanced math, we start teaching you at this level, radicals in the denominator are not allowed, okay? So to simplify an expression that has a radical in the denominator, that process that I'm going to teach you is called rationalizing the denominator. If the denominator is a monomial, that means, for example, the denominator is 2 root 6. That's a monomial. Or root 5 is a monomial. but not where you have a denominator like 2 plus root 5. That's a binomial, which we'll deal with on Monday. If there is a monomial square root denominator, you multiply the top and the bottom of the fraction by the radical that's contained in the denominator. So for example, if you did some work out of maybe example 1, and you landed here, this is your answer. You look at it and you say, well, can I simplify 5 over 2? No, it's already simplified or reduced down. Can I simplify root 3? No, it's not like root 8 or root 12 or something like that. But then you would say, I don't want the radical in the denominator. How do we get rid of it? Like it says in that box, you multiply the top and the bottom of this expression by the radical in the denominator. We don't use the 2, just the root 3. So what will that give us on the top? Well, it'll give us 5 root 3 on the top, right? What will it give us on the bottom? It's going to give us 2 root 3 root 3. Can somebody explain why we are allowed to do this without changing the value of the expression? Because if we're allowed to change the value of the expression, I can get rid of the radical very easily. Right? You're not allowed to do that. It has to have the same value. Why is multiplying by root 3 over root 3 allowed? Sukma, do you know?
Because if you divide root 3 by root 3, it's 1.
Right, root 3 over root 3 is simply 1. We're multiplying it by 1, we're getting the exact same thing, because anything times 1 is the same thing. It's going to look different, but it will be the same. So what do I get on the bottom? On the bottom, I get root 3 times root 3 is just 3, times that 2, I get 6. So right now, what I would like you to do is convince yourself that this and this are in fact equal to each other. By taking your calculator and taking 5 divided by 2 root 3. Now be very careful here, because when you enter 5 divided by 2 root 3, if you do this, your calculator will not divide by the root 3. It's only going to divide by the 2. If you want to enter it in one shot, then you need a set of brackets around that entire bottom. That's the original expression. And now we have 5 root 3, close brackets, divided by 6. It's the same thing. Okay? This is why, back in the trigonometry unit, when we found the length of a side of a triangle to be 1 over root 2, I told you, and I hope you remember this, that these two things are the same. I didn't explain why, but they are the same, because if I take 1 over root 2 multiplied by root 2 over root 2, I'm rationalizing the denominator, I get root 2 in the numerator and 2 in the denominator. So, for example, simplify this expression. First of all, can I reduce 30 over 20 down to lower terms? I'm asking if I'm allowed to. The answer is no, because the 30 is a coefficient. It's not a radicand, and the 20 is a radicand. I cannot mix up the different pieces in operation, so there's nothing I can do there. Here's one option for simplifying this. Multiply top and bottom by root 20. And what we're going to get on the top for the numerator is 30 root 20. And on the bottom we will get 20. Can I simplify 30 over 20 here? Yes, they're both coefficients now. And that's 3 over 2, so this is 3 root 20 over 2. Can I simplify anything else? Yes, root 20. You got this checklist that you're always going to be going through. Can I reduce the coefficients further? Can I reduce the radicands further? Did I get rid of a radical in the denominator? Are any radicals simplifiable? Well, root 20 is pretty easy to simplify. Root 20 is root 4, root 5. It's 2 root 5. So now we have 3 times 2 root 5. And remember, you work top down. If I didn't leave you enough room in that space, you work top down. If you've hit the end of the line, then do this and continue writing. But you don't go equals, equals, equals left to right. This is over 2. Well, I can divide this 2 by this 2 because they're both coefficients. So I'm left with 3 root 5. Are we okay with that? Could you have instead said, you know what, I'm going to simplify that root 20 first. So I'm going to write this as 30 over the 2 root 5. Can I simplify 30 over 2? Am I allowed to? Yes, because they're both coefficients. So now I get 15 over root 5. I got to multiply top and bottom by root 5, giving me 15 root 5 over root 5 times root 5 is 5. Well, 15 over 5 is 3. You're left with 3 root 5. And you might, there's the 3 root 5. You might say, well, it's obviously simpler or quicker to simplify the radical first, but you'll be surprised. Sometimes it is, sometimes it isn't. It's a really weird thing. Bottom line is, the answer is 3 root 5. Let's try another one. Root 68, 60x to the 8 over root 75x to the 5. Well, what we do here is we think of it this way. You don't necessarily need to write it down this way. But I divide coefficient, or I divide radicands by radicands. So I can figure out what, if you like, you could think of it this way. I don't care. I've decided to split it up into 2 radicals there, but it doesn't really matter. Can you simplify 60 over 75? They're both divisible by 5. I think it's going to be 12 over 15. Oh, which is 4 over 5, isn't it? So 4 over 5. The bottom line is we're going to end up with a 4 over 5 under the square root. I regret splitting up these into 2 square roots. I don't think it does anything for us. And then we're going to have x cubed. Do you notice where I wrote the x cubed? I wrote it in a place so that it's very clearly in a numerator. Well, the square root of 4 is 2. So I get 2 square root x cubed over square root 5. So I just better make sure I explain this. I have 3 factors, so to speak, that are under the square root. The square root of 4 is 2, so I've done that and I've written it outside of the square root, and then I'm left with x cubed over 5. There are 2 things we need to take care of here. One is the root x cubed can be simplified, because root x cubed, lots of ways to think of it. I kind of really hope that everybody understands that's what it's equal to. There's an x squared in the x cubed, which I can extract, leaving it as x on the outside, and then I have 1x left on the inside. So this is where I'm at. Just want to give myself a bit more room. So now I have 2x root x over root 5. Is that satisfactory for an answer? No, because there's a radical in the denominator, and we don't want that. So I multiply the top and the bottom by that radical. And on the top, that 5 can join forces with the x underneath the radical sign, and the denominator is 5. Not that it really matters, but x must be greater than or equal to 0, because in the original expression, there's an x to the 5. And if x were negative, x to the 5 would be negative, and you cannot take the square root of a negative. Any questions with that example? All right. Well, I'm just going to begin by rewriting this as negative 5 root 5 over 8 root 7r. I want to back up, and it's a technical issue, but in math, technical is the best way to go. My restriction, I said x is greater than or equal to 0, is incorrect. My restriction should be x is greater than 0. And the reason for that is a denominator has x in it in the original expression. There's an x there in the bottom. Before we simplify, there's an x in the denominator. If that x is 0, you will be dividing by 0, which is not allowed. Okay? It's not a big deal. Not a big deal at all, but by the time you get to 30, it becomes a big deal. Okay? And the reason why I was thinking of that is I was about to tell you that this is the restriction for r, and then I realized, well, wait, you're dividing by r. You can't divide by 0. So r must be positive. Can't be 0, can't be negative. There's only one thing wrong with this, and it contains a radical in the denominator. So we multiply top and bottom by that radical. I know that I feel sometimes it's obvious, but I better make sure you understand. We do not want to multiply top and bottom by 8 as well, only the radical. If you do multiply top and bottom by 8, I guess that's okay. You're just going to end up canceling them later because you have to reduce those numbers down. We're almost done here. This is negative 5 root 35r over 8 times 7r. So on the top, that root 5 times root 7r is root 35r. On the bottom, the root 7r times root 7r is just 7r without a root, which means we can write that as 56r. And we're done. Don't bother searching for simplifying 5 over 56. You can't. If you could, you would have seen it up here, because 56 is 8 and 7. Yeah?
Shouldn't be like 56r divided, we can divide 35r by 56r and get the r's out.
Can somebody explain why we are not allowed to get that r out? It's not under the radical in the bottom, right? And by the way, if you start doing that here, you're working your way back to the original problem, and you're not going to get rid of that radical. So be very careful here. The r in the 7r that I've highlighted in yellow is a coefficient type r. It's not under a radical, whereas the r highlighted in the 35r is under the square root sign, so it's a radicand. You can't mix and match. It would be very similar to me. If we go back, just see if I can find one here. It would be very similar to me. I guess we don't really have one. Let's imagine that this number here ended up being a 10. You cannot cancel this 10 with this 5. Okay, you got to be very careful about that. 14 minus root 40 over root 20. Well, let's try simplifying. We've got a couple of radicals in there that can be simplified. Take a minute and simplify these two radicals just off on the side. How many of you just know what they are by looking at them? Yeah. Root 40 is 2 root 10. Root 20 is 2 root 5. Now, because it's root 4 root 10, and it's root 4 root 5. I want to talk, before we rationalize or do anything else, I want to talk about this expression here. And do you see that this has the same basic structure as what comes out of the quadratic formula? It's not quite the same because we never have a radical in the denominator, unless maybe you're working on your assignment where you might have a radical in the denominator. We've talked about this before. Am I allowed to take these two numbers and divide them? So the question on the table right now is, am I allowed to say that this is 7 minus 2 root 10 over root 5? No, I am not. Am I allowed to cancel these and have 14 minus root 10 over root 5? No. What am I allowed to do? Yeah.
Subtract the 2 and then divide it?
Can you repeat that? Maybe explain what you mean by that?
Like take 2 out of 14 and then divide it by?
Right. So we can factor a 2 out of the numerator and have 7 minus root 10 all over 2 root 5. And this is going to be so important for the unit after this one. You were only, I wish I had a tattoo of this. You were only allowed to cancel things if they are factors of the top and the bottom. Okay? So what is a factor? A factor is a quantity that is in brackets multiplied by the rest of the expression. 2 is a factor of the numerator. 2 is a factor of the denominator. So we can cancel those now and be left with 7 minus root 10 over root 5. And the shortcut I have shown you is, I asked, are you allowed to cancel a 2 out of those two? And the answer was no. Are you allowed to cancel a 2 out of these two? And the answer is no. But you are allowed to cancel out of all 3. That's the shortcut. So I think it's better to get to this point, and now we're going to multiply top and bottom by root 5. Why are we entering into that venture? Because we don't want a radical in the denominator. I don't believe I'm going to do this, but if I would have gone back to the beginning and multiplied top and bottom by root 20, do you see the numbers would get very big very quick? And then I would have a lot of reduction to happen, because I'm going to end up with a root 800 on the top if I multiply top and bottom by root 20. So what do I get? Well, on the bottom I get 5, and on the top I get 7 root 5 minus root 50. I have to take this root 5 and multiply it by both of those because it's being multiplied by a binomial. It's no different than taking x minus 3 times 2, except we would probably see it as 2 times x minus 3. Sometimes these questions are like a piece of gum that just, you try to get it off and it just sticks to something else. There's always more work to do, it seems. Because we've started by simplifying these radicals that could be simplified. Then we've rationalized the denominator. And now we've got another radical that appears out of somewhere that can be simplified. Root 50. which is 5 root 2. Oh, can I cancel these two 5s? 5 is not a factor of the top. If this number here were 10, then I could factor a 5 out and cancel. But it's a 7. So that is our answer. And I know that we're starting to get into an area where I think sometimes you listen to what I say about what's expected on exams and you go, this is getting a little heavy. But if you've been in this class when I've been working with my Math 30s, it gets pretty heavy. So I could have given you this question and said, PD simplifies it completely and gets A root B minus C root D over 5. What are the values of A, B, C, and D? And this is not something that you can just look at and see what A, B, C, and D are. You have a lot of work to do to get there. One last one. Even though sometimes it backfires, I think it's better to simplify radicals early on to begin with. I shouldn't say backfires. What happens is you simplify a radical only to have to simplify radicals again later. But if you don't simplify to begin with, then yes, you only have to simplify radicals once later, but the radicals will be quite big.
We have a 2 in front of the 18.
You have a 2 in front of the 18? Thank you. Is it written correctly now? Okay. Let's simplify root 18. Give some thought as to why root 18 is 3 root 2. Root 18 is root 9, bless you, root 2, which is 3 root 2. So I have 3 root 6 plus 12 over 2 times 3 root 2. Am I allowed to multiply these numbers together? Yeah, they're both coefficients. By coefficients, I mean they are not under the radical sign. So I get 3 root 6 plus 12 over 6 root 2. I'm not saying not to do this, although I'm not going to. Why don't do this? Why, although this does need to be done, why should I wait and hold off on doing it? Or what can I do instead?
Could you factor them all out by 3?
Right. I can reduce things down by a factor of 3. I can factor a 3 out of the top, and there's a 3 as a factor in the bottom. And I think it's the same thing that I was just talking about with regards to rationalizing. If you can get the numbers to be smaller earlier on, your work later is lighter. It's not as heavy in terms of the lifting. So we can take a 3 out. And I would say, everybody, I shouldn't need to do this. But in keeping with my idea that things that cancel are in a set of brackets, I'm illustrating why we can cancel a 3 out of that 6. So these go, I'm left with root 6 plus 4 over 2 root 2. Now I can multiply top and bottom by root 2. Root 2 times root 6 is root 12. Root 2 times 4 is 4 root 2. And on the bottom we have that original 2 that's in front of the root 2 And then we have our root 2 times a root 2, which is 2. So we're going to have a 4 on the bottom. I hope you appreciate that as things pile up, and this is not just the beginning, but there's more to be piled or layered on top of this next week. We don't have time to start writing 12 as 2 times 2 times 3. You should know that root 12 is 2 root 3. Are we okay with that? Okay. So what do I get? I get 2 root 3 plus 4 root 2 all over 4. This is like zombie math. Like we think we've got it beat, and then all of a sudden it rises up again. Because now we can factor a 2 out of the top. Had you not factored the 3 out up here and canceled, then you would have had larger numbers here, and you'd be able to factor out a 6 instead of just the 2. So I take a 2 out, and I'm left with root 3 plus 2 root 2 over 4. 4, of course, is 2 times 2, so we can reduce the top and the bottom by a factor of 2. And get root 3 plus 2 root 2 over 2. And this stuff, you know, it started off pretty simple. Divide coefficients, divide radicals. It gets quite involved. So if you look at, I would be really hesitant to give this to you as a multiple choice question. Look at all the work, man. The reason why I wouldn't give it to you as a multiple choice question is because if I did, all you have to do is put this into your calculator if you had the wherewithal, and then put choice A, choice B. And I can tell maybe by the expressions on some of your faces that that's what you do sometimes. Well, I did that a lot, particularly in junior high and grade 10. By the time we got to grade 11 and 12, teachers were like me, it doesn't work anymore. Okay? So I would give this to you as a numerical response question. This is equal to root A plus B root C all over D, or part of a written response. Anyway, that's it. That's all for the lesson. You're not doing the textbook today. You're looking at the very next page of your unit handout, and there are a variety of questions there. I don't really believe you have enough room on that paper to do them, so you should be doing them elsewhere.